In this video, I'm going to show you a very useful theorem on limits. Maybe you might want to pause this video and have a quick read of this. But what it's saying is that let the limit of the well, suppose you're given something like this here. If you let's say this bit here has a limit. So well, first you got to learn how to read this. So reading this here is saying let the limit of f of x as x tends to a here. Let's say it has a limit, and that limit is anything other than 0. So reading this here, reading this here, hang on. So whenever you're given a limit problem like this here, what it's saying is that suppose this bit here has a limit. Okay, so it's saying this thing here has a limit, and that limit is anything other than 0. So other than 0, anything other than 0. Okay, now having a look at this here, it's saying well, if this limit here, if this has a limit other than 0, and this one happens to be 0, then the limit of the whole thing here does not exist. Okay, so basically, whenever you're given something like this, if the limit of this here has a limit other than 0, that's what this bit is saying here. It has a limit other than anything other than 0. So if this has a limit other than 0, and the limit of this is equal to 0 here, then the whole thing here does not have a limit. Okay, that's what it's saying. So for example, looking at this reciprocal function here, so this is like f of x equals 1 over x, and suppose you want to find out the limit of 1 over x as x tends to 0 here. Well, looking at this here, hang on, let me move this up here, right there. Let me move this up. So this is our this is our function here. Well, looking at this here, you see, this here is this bit here. So looking at this bit here, I'm in effect saying, oh, our first function is 1. Remember, the number 1 is a function. It's just like me having a graph of y equals 1. That itself is a function. Okay. Now the g of x in this case, I'm saying g of x in this case is x. So I'm saying I've got a function y equals x. So this here is like this function here. Okay. Well, anyway, well, as x approaches 0, so well, the limit of well this thing here, looking at this here, this is like me saying the limit of 1 and the limit of x here. Now as x tends to 0, the limit of this is 1. Okay, the limit of this is 1, and then as x tends to 0, the limit of this will be 0. So here we've got a limit, a definite limit. We have L1, a definite limit other than 0, because 1 is anything other than 0. And then looking at this part here, down here, the limit here is 0. So if whenever you have a limit at the top and at the bottom is 0, then you can say that the whole thing here does not exist. So because I've got a definite limit and something that is 0 at the bottom, then I can say the whole thing here does not exist. So you can see that here, as x approaches 0 here, the limit does not exist. Okay. So another example is this here. Hang on. So suppose you've got this here. So this here is a function. The red line here is this function here. Now as x approaches, as x tends to -2, so -2 would be somewhere around here. You've got an asymptote at -2 here. So clearly you can see that the limit does not exist. From the left hand side, it heads towards -infinity. From the right hand side, it heads towards positive infinity. So looking at the graph, we can clearly see the limit does not exist. But by just looking at, by using the theorem, as x tends to -2, so this thing here will be -2 here. So you've got -2, take away 2, that will be -4. Okay, and then if you put this into here, this will be -2 squared will be +4, and then you take away 4 here, so that would be 0. And then the theorem is saying that, well, if you have a limit here, you see this here, you can see that this here is one function, this here is another function, and here we've got a case where this has a definite limit. The limit of this is -4, and it's a limit other than 1, so sorry, other than 0. So it is a limit, and it's not 0. So yeah. So and then this one here, this function down here, the limit of this as x approaches -2 is 0. So here we've got a situation where this has a definite limit other than 0, and this one has a limit of 0. Therefore, then we can conclude that therefore the limit of the whole thing does not exist. That's what the theorem is saying. Hang on. That's what the theorem is saying. It's saying that if the limit of this is anything other than if it exists and it's anything other than 0, and the limit of this is 0, then you can say the whole thing here, the limit of the whole thing there does not exist. Okay, a very useful theorem.